This video is going to cover sensitivity and specificity, which are ways of evaluating a test in comparison to a gold standard test. So just to start off with, a gold standard test is a perfect test that has no false positives and no false negatives. They're often kind of hypothetical, but there are a few gold standards out there, and they're useful for evaluating the accuracy of a more efficient test, like a field test, in comparison to this expensive or time-consuming gold standard. So just to kind of illustrate this, an example of a field test is if there's like a questionnaire that you can administer either to someone who may have experienced a stroke or a family member of that person who can answer on their behalf. And that might give some information about how likely it is that they truly had a stroke. Well, the gold standard would be something like an MRI diagnosis of a stroke, where it's pretty certain. And they both have their relative strengths and weaknesses. So for the field test, it's cheap and fast, but it's likely to be pretty inaccurate. And the gold standard is really accurate, but it's expensive and slow. So if we can find a field test that has comparative accuracy to the gold standard, but is a lot less expensive, then it might be more useful in a field setting. So this is an example of the way a table is set up to compare a test to a gold standard. So this kind of disease positive, disease negative is the true state of people, and that's what the gold standard would show. And on the left here, test positive and test negative are the imperfect results from this test that we have come up with. So the true prevalence of the disease is the number of people that are truly disease positive, so A and C, and divided by everyone. So the number that are disease positive divided by all of the people in the population or in the study. The observed prevalence is the total people that the test said have the disease divided by everyone, so A plus B over everyone. However, the test is imperfect, and there are situations where our test and the gold standard agree, so true positives, and there's times when the test says the person has the disease, but they really don't, so that's a false positive. There's also true negatives where both the test say the person's not diseased and the gold standard does, so true negatives. And there's times when the test says the person doesn't have the disease, but they do, so it's a false negative. And the test results don't often agree perfectly with the true results, and sensitivity and specificity is all about quantifying the extent to which it disagrees with the real situation. So sensitivity is often short formed to SN, and it measures how well the test identified disease positive individuals, while specificity, often short formed to SP, measures how well the test identified disease negative people correctly. So starting out with sensitivity, just for the statistical notation, this is just saying the probability that a person's test positive given that they're disease positive. And this is same as saying the probability of testing positive if you're truly positive. And the way that would look in the table is A over A plus C. So the proportion of this cell over all that are disease positive. The proportion that tested positive over everyone who was actually positive. Specificity is the probability of testing negative given that you're truly disease negative. So yeah, that's basically what I said. And yeah, that's D over B plus D. So the proportion of true negatives out of all of the truly disease negatives. So here's an example with numbers in those cells, showing the proportion that are true positives, true negatives, false negatives, and false positives. If we were to find the true prevalence, it would be A plus C over everything. So working that out, it would come out to 40%. The observed prevalence is the number of people the test called positive over everyone, and that comes out to 55%. So there's a bit of deviation there. Pretty much as soon as these cells are populated with anything, we know that there's some differences in what the test said. But as far as quantifying in what way and to what extent it's that our test is wrong, we can look at the sensitivity. So the proportion of the test positives, proportion of disease positives that we were able to get with our test, so A over A plus C, and that comes out to pretty good sensitivity. We have 93% sensitivity. We were able to capture 93% of the truly diseased people. Specificity is D over B plus D, and that comes out to 70%. So specificity is quite a bit worse. That means that of the people that are truly disease negative, we only correctly identified 70% of them. So basically what we learned about our test is it has good sensitivity, so it's good at finding the disease when it's there, but it doesn't have great specificity because it's bad at correctly identifying disease negative people.